Good evening, everyone. Welcome to the class again. I see we're just three of us that have joined. So, as usual, I will still give a few minutes for us to join in before we kick off. Hope everyone is doing well. It's good to see you all again. So let's just give a few minutes, maybe about 3 to 5 minutes, then we'll crack on. Thank you. Good evening. Good evening, everyone. Good to see you all join. Emmanuel says, first time I'll be joining the live class due to work. Really excited. Wow. Nice to, all right. Hope you all can hear me. Emmanuel, it's good to have you join us. I was just gonna say, I hope you've been able to catch up with the different classes, the recordings that we've had so far. Hope you've been able to get the gist of what we're doing, and with the break we've had for everyone to practice. Yes, and really get some questions. Okay, awesome. Great to hear that you're following up with the classes. So I hope we've just had used the time to catch up. That's to everyone. I really hope so. I hope the break was very helpful for everyone. So seeing that it's 10 minutes past, trust that other people will join us. Maybe they're still enjoying the break way too much. But if you know someone that's supposed to be here, that is one of your colleagues, someone you speak to, you could just give the person a nudge so that they can join us, so they don't miss the interesting things we're going to discuss. So we'll just dive right into it. As usual, there'll be a time where I'll ask for questions, and if you have questions, please just note them down. When it's time for questions, we'll take them and run through them. If there's something wrong with either my audio or my screen sharing or something, and just put it in the chat also. I'll be checking that intermittently so that I can make sure that everything is going fine at every point in time and everyone can hear me and get the gist of what I'm saying. All right, awesome. So in the last module of this foundations course, we would be talking about containerization. Containerization, and we'll be starting with containerization with Docker, right? We're going to talk about some introductory topics in Docker and containers. And we're going to talk about Docker images, containers, like I mentioned, and just do a summary at the end of this. So we're going to just start with an introduction to Docker itself. But before I even go into the introduction to Docker, just want to talk a bit about containerization and the concept of containerization very quickly. Containerization just refers to running your software on containers, right? Making your softwares to be able to run on containers. And we'll dive deeper into that. I just don't want that word to be something that is strange to you whenever I say containerization. It sounds like a big word, but it's basically just running your software in containers. Just like when I say virtualization, it's running your software on virtual machines, which people are more used to, right? So that's that. So now to Docker. Docker is a platform that enables development deployment and execution of applications inside containers, right? Think of Docker like a magic box, because when I first learned it myself, it seemed like magic, like a magic box that allows you to package your application and all its required tools and dependencies, making it easy to run it anywhere, like ship it to anywhere, any platform, any operating system, and run it anywhere that you want to run it, right? Containers are lightweight, portable, and self-sufficient units that encapsulate an application and its dependencies. It ensures consistent performance across different environments, right? I don't know if you have worked with virtual machines before. I will just describe where the concept of, or why the concept of containerization and even using Docker became a thing. But if you've used virtual machines before, which I'm sure you have because you've worked with EC2s, right? From our previous topic. So EC2s are virtual machines, basically. Virtual machines would usually have like an operating system and different other applications that enables it to run, right? Let me give this example. I don't know if you've used a Windows machine, you know that you'll constantly need to update the drivers. If you've played games, for instance, on a Windows machine, you'd have heard of something called DirectX that you need to install. Basically, there are some softwares that enable the operating system or a particular application to run very well. For instance, if you're using, let's say, Adobe Photoshop or something, sometimes you need to install something called Adobe Creative Cloud, Adobe CC, right? So it's basically the concept of understanding what dependencies are required by an application to run successfully and packaging all those dependencies into one lightweight. Okay, let me know. Can you hear me now? Sorry about that. I didn't know that audio had gone. Yes, but thank you so much for calling my attention to that. It seemed my mic, the battery of my mic died. Okay, great. So let me just kind of do a recap of the few things I said before, or after I lost audio. So I was just trying to say that using Docker is like having a recipe for a meal that guarantees that your meal turns out the same way, whether you cook it in your kitchen or my kitchen. All right. So Docker provides the recipe and it provides the ingredients, basically. So it's just saying if you follow this recipe and use the same ingredients provided in your kitchen and in my kitchen and in Eddie's kitchen, then you will constantly get the same results, right? So in software terms, it's saying as far as you have the same Docker image, and we'll talk about that, and you have Docker installed, whether you're on Windows, whether you're on Linux, whether you're on Mac, whatever operating system, the software will still run the same way, right? Because the Docker platform enables that to happen, right? I will dive deeper into that. So talking about an overview of the IT industry before Docker and containerization, because containerization was not always a thing, right? It wasn't something, that existed some 20 years ago, right? Prior to the containerization era, the IT industry software development and deployment had a significant challenge known as "it works on my computer." So this concept is one where you develop an application, let's say company, not even company, let's say department A, let's say the dev team, they develop an application, right? And one of the developers develops it and sees that, oh, it works fine on his computer because he has installed everything he needs to install. Maybe the application needed him to install a HTTP server. It needed him to install, some drivers and all those kind of things. So it works fine. Then he sends the application over to the quality assurance team. And the quality assurance team tries it on their laptop and they're like, this application does not run. It's throwing errors. Then they get back to the development team. The development team is like, but it works on my computer. So it's not my fault, it's your fault, right? That means you are doing something wrong on your computer, right? So this was an issue prior to containerization, because in order for software to run the way it is expected to run, every computer had to have certain things installed, like certain softwares, and they can be as many as 20, 30. And that was just a big pain, right? So that issue arose from inconsistencies between development and production environments. That was also a big deal. It's not even just between teams. It's like when you develop an application on your development environment, and in your what's it called now, and you then push it to production. It works fine in development. You push it to production and you see issues that you never saw in development, just because development and production have two different servers that might have something's missing between them, right? In terms of software, in terms of binaries, in terms of drivers, or whatever you want to call them, right? So developers will often encounter difficulties when transferring applications from their local development environments to production servers, as the dependencies and the configurations might differ, right? Maybe on their local environment, maybe they did it on their laptop, and the configuration of their laptop had 8 GB RAM and let's say 24 cores or something, 24 core CPU. But they push it to production. Production has only 2 GB RAM and 12 core CPU. And they say, oh, it runs fine on my laptop. We don't know why it doesn't run on production. The reason why it doesn't run is because they have two different configurations, right? And the way the application was created, it wasn't created in a way, or it wasn't created with a platform that can ensure consistency across various operating systems and various machines, right? So this kind of problem resulted in delays and increased operational complexity, right? And that's where Docker and containerization came in to address the challenges by providing a lightweight and portable solution that encapsulates applications and their dependencies, ensuring consistency and reproducibility across different environments. So when we say dependencies, the word dependencies is something you see a lot in the DevOps space, right? Dependencies just says, or just means rather, the different things that are required by an application for it to function, right? So let me give an example. If I am an athlete that runs, let's say I do a 100-meter race. As an athlete, one of my dependencies will be my shoes, my running shoes, because without my running shoes, I cannot, compete, right? Or a dependency might just be my feet. Imagine if I don't have feet, how am I going to run? So dependencies are the things that are needed for an application to run successfully, right? And the ability to package the application together with its dependencies in a lightweight manner was really a game changer. in the IT industry. Previously, you would do that with virtual machines. But the interesting thing about virtual machines is that virtual machines were very large, right? In terms of the amount of disk space they take and the amount of, resources they need, CPU and memory, being that you had to install a full-fledged operating system on every virtual machine. Like, even though you needed maybe just 5 applications there, and a virtual machine will usually have maybe close to 50 or 100. You have to install all those hundreds, right? And they will have to be running, even though you just need 5 out of them. So Docker just wins in the sense that it slims down the things that you need by stripping out the unnecessary things and just making the very necessary things, that those are the dependencies, available for the application to run successfully, right? So let's just look at the advantages of containers before I take some questions. The advantages of containers. So containers are, like I mentioned, just giving another analogy, they're like suitcases that are packed with everything the application needs to run. Software, libraries, configuration files. No matter where you open the suitcase, everything is there to work exactly as planned, right? This ensures that you can move your application from your local desktop to a cloud provider in another country without any issues, right? So it makes it easy for you to move applications across different environments, right? So that's one great advantage, that's portability. You can go from cloud provider to cloud provider, local environment to cloud provider. On Docker, if you run an application on Microsoft Azure, you take that same application, take it to Google Cloud, it's going to run seamlessly. Take it to Amazon Web Services, it's going to run seamlessly. Take it to Oracle Cloud, it's going to run seamlessly. The same as far as they all run Docker, right? One of the other advantages is that it's resource efficient compared to virtual machines. I already talked about this a little bit, right? Unlike virtual machines that require their own full-blown operating system, containers share the host operating system, making it lighter and faster, right? What that means is that it takes some things from the already existing operating system on the host to run, and it just brings the things that it needs, the extra things that it needs, basically, right? So you can think of, I'm sure we should be familiar with virtual machines, but you can think of virtual machines as full apartments with their own infrastructure, while containers are more like rooms in a shared house with common utilities. So when you have a shared apartment, you have your room, but like you share, let's say kitchen, you share bathroom, you share living room, those kind of things. So essentially you need just your room, right? In that case, maybe you might need to stay there for a night rather than renting the whole place for like a year or something, or a month. You can just rent only the room that you need, and move on, right? So it's quite resource efficient. It has faster startup times and better utilization of system resources, right? Another advantage is that it allows for rapid application development and scaling, right? Being that containers are very, very lightweight, like I mentioned, very portable. So they enable agile and scalable application development, because when you are scaling, you always have to think of how long does it take me to scale from, let's say, 1 server to 5 servers. If the servers are so, big and they take a long time to start up, then your scaling process is going to be delayed. But being that containers are so lightweight, if you're going to scale from 1 to maybe 5 containers, it can take you like 90% less time compared to maybe using virtual machines, right? So you can rapidly scale the containers to respond more dynamically to demand without the need for extensive setup of different things, right? Another advantage rather is the ability to package applications and their dependencies into lightweight portable containers. It addresses key challenges in software development, and it streamlines the development process and promotes collaboration between development and operations team, right? Because it reduces the chances of bugs and different operational issues because they are testing with the same platform and they are testing basically the same software, right? So it just makes everything smoother. So I'll just stop here to get a few questions before I proceed, because we believe that some of us have questions based on what we've heard. I'm sure you're just trying to visualize what I've been saying if you have not used, Docker before anyways. So please, if you have questions, raise your virtual hand. I'll give you the opportunity to speak. I see Papa and Stephen with their hands raised. Is this from the time when my audio went out, or you actually have a question? Papa, if you have a question, please go ahead. Give me the ability to unmute and ask a question. Since I see your hand up, oh, your hand has gone down.
No, it was from before to tell you that your sound was off. Sorry about that. I forgot to take it down.
Yeah, that's all right. Thank you for that. Okay, Bolaji has a question. I'm sure his question will trigger more questions. So, Bolaji, please go ahead.
Hello, good evening all. Thank you so much, Wisdom. My question might be related to this. Two questions. Number one, is it a yes? I'll appreciate a yes or no answer. Is it to be a successful DevOps engineer? Do you need to have programming skills, not scripting skills? I know scripting is for automation and all. Bash. Is it mandatory to have programming skills, or is it avoidable for people like us that want to avoid it? That's question number one.
Okay.
Then the other question is, now you have explained it that the main difference between VMs and Docker is VM is like the bungalow and Docker is like a room in it. Right? So that's the big explanation that is very simple. But now in Docker, maybe when we let me suspend the second question for now. Maybe but as time goes on, maybe the question will be answered. So that question, is it mandatory to be a programmer, to be a successful DevOps engineer? Thank you.
All right, thank you so much for your question, Bolaji. I know you want a yes or no answer, but it's not going to help you if I give you a yes or no answer, if I'll be honest. So there are many factors involved in this. Is it mandatory for you to have programming skills to be a successful DevOps engineer? First of all, it depends on what you define as programming skills, because some will tell you that scripting is programming at the end of the day. Second of all, it depends. It depends. I see you in those comments. It depends on what you define as successful DevOps engineer, because the truth is, you will find yourself maybe working in different companies that require different skill sets, right? Except if you stay for one company for a long time. So you never really know. And even if you stay in one company for a long time, companies do what we call a pivot sometimes, or some people call it a pivot. And what that means is they might be going in one direction and using certain software, but just change direction due to some reason. Maybe they want to chase a different market or something like that. And the engineers will need to kind of adapt to that direction to be very agile in that sense. So what I would say is it is very beneficial for you to know a programming language, not necessarily to be an expert in it, but for you to understand the concept of programming, understand the concept of scripting, because I'll tell you the truth, a lot of software practices are really going into, they are really moving away from working with your mouse and your keyboard in terms of clicking, excuse me. They are really going away from that interactive method, right, of deployment and management. They are going towards the codified method of deployment and management. That's why you hear things as like infrastructure as code. That's a major part of DevOps, infrastructure as code, right? So firstly, I would say you don't need to be afraid because the way things are going, especially in the DevOps space, the code is human readable code. It's something that the way they would usually do it is like you have like a noun, then a verb and something like that. They make it in a way that a human can understand and write that code. And there is sufficient documentation everywhere for anything that you need, right? So if you can understand the ones that you click around, you would definitely be able to understand the ones that you need to write code for, right? So I'll give you other examples. When we talk about DevOps and we talk about running CI/CD pipelines and all these things, when you have been hired as a DevOps engineer to create pipelines, maybe they need you to create about 40 or 50 pipelines for different projects. You're not going to be clicking around. That would take you like weeks to do. You would have to write the code for it and reuse the code, write your code in a way that you can reuse it in several places. So there are so many advantages to being able to write your code. If I were to answer your question more directly, is it avoidable? If you avoid it, you miss out on a lot of opportunities, right? And if you avoid it, you make yourself kind of short-handed when it comes to, the selection processes for various jobs. But I don't want you to see coding as the I don't want you to see coding as, the way it was in the past, in the sense that, oh, developers have to have written code for many years. You have to know C++. You have to know Java. Nobody does that again. I mean, those are very niche languages, right? Something like Python is human readable. Something like Go is human readable. Even Bash script, like I said, these are things that they're quite easy to learn. And the more you practice, the better you get. So they look scary in a sense because it's called programming, but really it's not that difficult. And as Oyeride has mentioned, AI is in the loop now. So that makes it even easier for you to learn anything you want to learn with the likes of ChatGPT and Meta AI, Gemini, and all those things, right? So I hope that gives some perspective to that question. Whatever is worth doing is worth doing well. And really, a lot of these things, you just need to understand the concept. Once you grasp the concept, it's just like when we were in school. If anybody did further maths here, right? It looks like the most magical thing ever, even mathematics at some point. But once you get the concept and you get, the formula, how these things work, you're able to build on that, but it takes some effort, of course, right? So yeah, thank you so much, Bolaji, for that question. Do we have any other questions before I move on? Any more questions? I see Emmanuel is typing. Okay, he's just responding to you already. All right. Okay, so I'll just move on since we don't have any questions. It seems like we're really getting the gist of what I'm saying, which is what's important, right? So this is really just emphasizing or, kind of digging deep into what I've been saying, doing a comparison between containers and virtual machines, right? So you can see here, let me zoom in a bit, although the image is not very clear right now, but I'll just give kind of like an overview of what they say. So when you run virtual machines, right, you have a server as the base level, right? The server might be like an EC2 on Azure VM or whatever it is. Then you have the host OS. That is the operating system running on the server, which might be your Windows or your Linux or your Mac, whichever one it is. Then you have what you call a hypervisor, right? A hypervisor is what enables virtualization, right? Then the hypervisor, for instance, might be something like your KVM, your what's the name of this popular or the name has skipped my mind, but yeah, you can help me in the chat if you remember the different virtualization, the different hypervisors, right? VMware, yes, VMware is what I was trying to remember. So you have things like your KVM, your VMware, you have your Hyper-V, which is like a Windows hypervisor, right? So that sits on the Windows, the host OS. You install that on the host OS. Then within the virtual machines, you now have what you call a guest OS, right? And on the guest OS, you have the different, binaries and all those kind of things that you need to install. Then you now have the application on it. So it's kind of like there is a lot that is involved in the virtual machine. But when you look at the container, right, you also have, like, using containerization, you have the server, right? You have the host OS. Then you have the Docker engine instead of the hypervisor in this case. On top of that Docker engine, you have your, your binaries and all those kind of things. Then you have your applications, right? You don't need another OS like you would have like the guest OS. They're basically just binaries. You don't need something fully fledged, right? You just have your beans and your libraries, right? It shares the operating system with the host OS. Right, so it says here, containers and virtual machines serve similar purposes, but differ in their approach, right? Virtual machines emulate an entire operating system, including a separate kernel, while containers share the host OS kernel, right? Like I mentioned earlier, virtual machines are like um, a fully fledged house, which has, its own amenities, everything, plumbing, electrical systems, and all the rest. They're fully independent, right? But think of the container as just a room within a house that shares the amenities of that house, but it itself, in itself, is just a room, right? It doesn't need those other things and to function, right? So you can have multiple rooms in the house, but you cannot have multiple houses in a house, if you get what I mean. You need separate houses, right? So it also mentions here that due to the lightweight nature containers offer improved resource utilization and performance. Now that happens because you are basically loading less amount of applications and software onto the host operating system when you're running containers. That means you're able to run more containers because they are lighter, right? For virtual machines, you can hardly see a virtual machine that needs less than 1 GB RAM because it's running a full operating system. But for containers, you can see containers that need 100 MB of RAM and maybe like 0.2 CPUs, right? That's like, yeah, like less than half, less than a quarter of the CPU actually. That's how lightweight they can be. So that means you can run more containers than you will be able to run virtual machines on a particular host OS. Like I mentioned, that enables for rapid scaling up and down. You can quickly create new containers and you can quickly destroy a container. If you're going to shut down a VM, it also takes a bit. If you're going to shut down a container, it's instant. Once you do that, it goes down immediately, right? So it has this different advantages like we have mentioned. So we're going to just take a look at some basic Docker commands, right? And we'll have these different commands that have been put here. We'll have the Docker run, we have Docker PS, Docker stop, Docker pull, Docker push, Docker images, Docker RMI. There are more commands. And there are more options for each of these commands. So these Docker commands run in a similar way to basically, how Linux commands run, right? You would have the word Docker, then you have an action. So Docker in this case is like the noun, then what comes after it is usually the verb. Sometimes it's the verb, right? For instance, in the case of images, it's not really a verb, right? But it's like Docker, then the action you want to perform. So Docker run is for executing containers, right? It creates and starts a container based on a specified image. I know we have not talked about images yet, but images are basically like, let's just call them like templates that Docker uses to run the container. So the templates already have everything that are needed to run that container, right? So Docker just runs it based on that image, right? It's like a blueprint. Yeah, I think that's another good way to look at it. It's like a blueprint, right? That it's used to start up that container. Docker PS is a command that displays a list of running containers, right? It enables you to check, oh, is this container currently running or is it dead? It's good for debugging, basically. Docker stop halts a running container, right? It's just like you're done with that container or there's something wrong with it, you want to stop it. Docker stop is a command you use. Then you have Docker pull. Docker pull is used to pull a Docker image from a registry, such as Docker Hub, to your local machine. Again, I know we've not talked about registries and we've not talked about Docker Hub itself. It's in our next few slides, but I'll just mention it a bit here. A registry is a repository of Docker images, like a repository of blueprints, right? So in that registry, you have an image for something like MySQL. You have an image for an Apache server. You have an image for different things, right? So they are stored in a registry, and there's a very popular registry called Docker Hub. It's run by the company Docker, the people that created Docker itself, right? So you can when you want to download that image from the registry to your own machine, use the Docker pull command. Then you have the Docker push command. It's similar to pull, but instead of downloading this time, it uploads, right? In a situation where you want to share that image, maybe you've created some Docker image on your local machine and you want to share it for other people to use, you can do a push, then others can pull it. Then Docker images just list all the locally available images on your machine, Docker images, that is. Then Docker RMI enables you to delete one or more images from your local machine. So what we're going to do is just to do a quick demo of this. I'm going to run commands with these different, take actions with these different commands, and let's see how that goes. I hope my terminal is big enough for us to see. I'm going to run the command. So bear in mind, you need to have Docker installed. I'm sure in one of your hands-on projects that would have been like the steps would have been given to do that. But you can always just search for, search for Docker online, right? And you can install something like Docker desktop, or if you go there, you see the different ways you can install Docker. I think this Springs probably. Right, so you see, these are the system requirements for you to run Docker on different environments. This for Windows, if you're on a Linux machine, they'll give you the way to install Docker. So it says install on Ubuntu, for instance. Let's see what this looks like. We can see it says just you want to install the desktop, you install these different packages, then you end up installing all this. Yeah, so it's quite straightforward when you just run it, because they've made everything easy in like scripts and all those kind of things. If you're running on a Mac, you can also choose which kind of Mac. Is it Apple Silicon or Intel? Then it starts to download the image for you, right? So yeah, that's pretty straightforward. The CLI is the local machine. Yes, the CLI I'm using, I guess that's what you're asking, because it's on my local machine. Everything I'm going to do now is on my local machine. You can have Docker running on some virtual machine somewhere if you want, on some EC2, that's fine. But the demo I'm going to do here is just on my local machine. Right, so if I do this command, I think it should be Docker version. You can see that I have Docker 20.10.12 installed on my machine at the moment, right? So I'm going to run a very basic Docker run command for us, right? So remember Docker run. Let me even show you this with like a little help. So it says run a command in a new container, right? So Docker run will take Docker run, and it will take an argument of the image. You can take some options, you can take some commands. You are not concerned with all this right now, but it just needs an image, the name of an image to run, right? So if we just run Docker run, nothing is going to happen, right? It says it requires at least one argument, which in this case is an image. So we're going to do Docker run, let's just say hello world. Hello world is an image that doesn't really, it doesn't, I won't say it doesn't really do anything, but what it does is just to tell you that it runs a script, right? That's what it does. And it tells you if everything is fine with your Docker installation and all those kind of things. So let's just run Docker run hello world and let's see. So it's saying unable to find the image locally. It's now downloading the image because I don't have it on my local machine. It's gone online to download that image. If you can see here, it says pulling from library hello world. I now checked, okay, actually I do have the image, funny enough, so it says already exists. Then this part here, hello from Docker, all these parts came from the Docker container, right? Hello from Docker. It says this message shows that your installation appears to be working correctly. And to generate this message Docker took the following steps, contacted the Docker daemon, pulled the hello world image. Docker daemon created a new container from that image that runs the executable that produces this output you are currently reading, and Docker daemon stream that output to the client, which is sent to the terminal. Basically, okay, so it's now giving us something interesting to do. It says to try something more ambitious, you can run an Ubuntu container with it, right? Let's try something ambitious since it's a demo. So to run an Ubuntu container, now think about this. Ubuntu is a whole operating system itself, right? And I'm now going to run Ubuntu as a container. Okay, so let's look at this. So I'll run what it says here. Docker run. This options IT just means run it in an interactive way. And an interactive way means that I should be able to type things into this container, right? If it's non-interactive, that means if I don't put this interactive here, what it will do is it will just run the container and it wouldn't give me any terminal to, type anything into the container. It will just run the container and come back to my normal terminal. And I'll show you the difference now. So let me run it without the IT so that you see what that looks like. So Docker run Ubuntu bash, right? So I don't have the image, it's downloading that image as you can see. Okay, says it already exists. So now it's run the container, but like it's come back to my normal desktop. There's nothing I can do with that container. I can't type commands, whatever. It's just run it and that's all. But if I run that same command with IT here, you'll see that to provide me with a new terminal, which is inside that container. So you can see this. This here is the ID of that container. So for every container you run, it has what you call a container ID, right? So this is the ID of this new container that I just ran, right? And so there's this command you can run on Linux machines. You can also Google it to just basically see what operating system is running there, right? You can use cat etc os, I think it's os releases, yeah, or os release, right? So this file just usually on most Linux machines store the name of the operating system there. So cutting this file, I just want us to confirm that I'm not still on my Mac, that I'm now on the Ubuntu machine, right? So you can see it says Ubuntu 24.04 LTS, and all those kind of things, right? Different things here. So it's interesting. Now, see how fast I was able to run an Ubuntu container on my machine. If this was a virtual machine, it would have taken me longer for sure. This was in like less than 5 seconds. And this is running now. So now, if I want to do my LS, as I will do everywhere, I can, create a new file. Let's say I want to, let's just use something like echo. Like I can echo, this is an awesome class into a new file called my new file .txt, right? Then if I cut that file, right, you can see. So basically, I'm able to use it as a normal operating system, right? So I have my Ubuntu running, very, very easy. So now if I exit from there, it exits from that container. Now I want us to do something here which is to run something called Docker PS. Docker PS, what it shows us is, I mentioned before, it displays a list of running containers. Now, I don't have any running container, and you would have thought that it should display this Ubuntu container here, but once I exited from the terminal of that Ubuntu container, it's immediately shut down, right? So depends on the way you run a container, it can either stay running or just shut down immediately. And you'll understand what I mean when we go into Docker files, right? Because in a Docker file, that's really where you define that blueprint that you use to create the Docker image, then use the Docker image to run the Docker container, right? So right now, we don't have any containers running. And if I do something like Docker PS -a, which is like to show all, let's see if it shows anything. Now, okay. So Docker PS -a shows both the running and exited containers, right? So now you can see the Ubuntu that I ran. It said it exited about a minute ago, right? You can see the hello. Excuse me. Sorry about that. You can see the hello world that I ran also exited about 6 minutes ago, right? So let me clear my screen now, and let me run something more interesting than just an Ubuntu. Let's run an Nginx server, right? So let's try this. Say Docker run. Let's say -it. Let's say, let's use -d. Now I want to use -d. -d means to run it in a detached fashion. That means that it allows me to interact with it, but at the same time, as soon as I run it, it will run in the background, right? It won't basically, be running on my screen and take up my whole terminal. It will run in the background. So anytime I want to access it, I can access it if I want to. That's what the detached means. So you can read about the options in the Docker documentation. There are so many options, trust me. I'm not saying that in a way to overwhelm you, but I'm just saying like there's so many interesting options that you can learn about to do different things that you want to do, right? So the next one we'll use is something called option P. Option P here is to do something called port forwarding, right? So we're basically going to say we want to map a port on my Docker machine to a port on the Docker container, right? Because if you remember, Docker container runs its own environment, and my machine, the host machine, runs its own environment, even though they share resources. But on the Docker container, since it has its own environment, it has like its own ports and everything that it uses, while my machine has its own ports, right? So if I want to kind of map from one port on my machine to a port on the Docker container, I'll use option P, right? So the first port I put here, let's just say 8080, for example, is the port that I want to use on my machine, my host machine. Then 80 is the port that is going to be running on the Docker environment, right? So what I can do is, in this case, let me give the Docker container a name. We have not done that in the past. So I just want to say a name. The name, let's just call it web server. That's the name I'm going to call it. Now, there's one thing missing if you guys have been following. And now that thing is the name of the Docker image that I want to run. So I put everything else, but I don't have the Docker image name, which need to use as the template or the blueprints to run. So the Docker image in this case is Nginx. because we want to run an Nginx server. So the last thing I'll put here is Nginx. Now, let's see if this is going to work. So I'll run this command now. So it says it's not able to find Nginx locally. It's pulling it. Okay, some things already exist. It's downloading a new image. Okay, great. So it's done. If it will run successfully, that was very quick. So let's do a Docker PS and see. Oh, okay. So we have a Docker image with the name Nginx running. Sorry, with the name web server running with image Nginx and a container ID that starts with DBOD, right? As you can see here. So it said it was created 12 seconds ago, and it came up. So it was created 30 seconds ago and came up 12 seconds ago. That means between the time it was created and the time it came up was 1 second, which is very impressive, right? Then it now says it has the port 8080 from the host machine forwarded to the port 80 um, on the Docker container, right? So let's see if we can access this. So I'm just going to try to access localhost port 8080 on my local machine, and let's see if I can get anything from that. So let's say localhost port 8080. Okay, great. It says welcome to Nginx. It says if you see this page, Nginx server is running, is successfully installed and working. Further configuration is required. So in 1 second, basically, and with one command, I was able to run the Nginx server, right? I think that is pretty impressive. So let's assume that I don't need this Nginx server running anymore, and I want to stop it from running. As you can see, it is still running here. If I do Docker PS again, you see that it's been running for 2 minutes. So let's just assume that I don't need it running anymore, and I want to stop it. So I'll just do the command docker stop. But what will I use to identify that machine if I want to stop it? Sorry, not the machine, that container in this case, right? There are two things I can use to identify the container here. I can either use the container name, web server, or the container ID. Both of them will work, right? So if I use the container name here and I just say docker stop web server, right? If it stops successfully, it will just return the name of the container. So if I do docker ps here, see that there is no container running anymore because it has stopped successfully, right? And if I go back and I try to access this, it should give me an error. Yes, because it's no longer running, right? So that's Docker stop for you. Then we have Docker pull. Docker pull, you've already been seeing it working here because you see pulling from library and all those kind of things. But before we do Docker pull, let's look at Docker images. Excuse me. If I do Docker images, it will show me all the Docker images I have on my machine. And there are a lot, but let's just focus on the ones we used recently. Things like Ubuntu, Nginx. Sorry, the formatting is a bit squished up because I have zoomed in. But if I zoom out a bit, you see that it makes more sense this way. This is what it's supposed to look like. It's just because I've zoomed in for everybody to be able to see, right? So we have Ubuntu, we have Nginx, we have different kind of images. These are just some other things that I've used in the past for work, some other projects. Yes, so let's assume that I want to delete this Nginx image now. I don't need it anymore. And I wanted to show you one more thing. Yes, good that we're here. Before I delete the Nginx image, I wanted you to see the size of this Ubuntu image that we run. It's just less than 100 MB, 76 MB. What if you were to run an Ubuntu image, you would need at least, if you were to run it on AWS, like on an EC2, you would need at least 8 gigabytes of storage to run an Ubuntu image, right? So you can see that there's a very, very big difference in this case. So going on, let's delete this Nginx image here, right? Because I don't need taken. So can run the command docker remove rm. So you can either say image, then Nginx, or in shorthand, you can just say RMI, right? So let's try it. So it says error response from daemon. It says unable to remove repository reference. This says you must force it because it's being used in an image, right? So once the image you're trying to use is still in use by a container that is exited. In this case, the container is not running, but if there's a container that exists that is using or referencing that image, it will not allow you to remove it straight away. You just need to do something called a force removal, which is using -F here. So if you see, if I put -F and I try to delete it, now it deletes successfully. Right? So it's deleted successfully. That's fine. So if I do the Docker images again, I shouldn't see Nginx anymore. So it's gone. Right? So in some interesting scenario, let's say I just need Nginx again. Maybe I removed it by mistake or too early. Maybe my boss comes and says, oh, please, we need that image now. I'm like, oh, I just removed it. It's like, okay, download it back. So what I'll need to do is to do a Docker pull and just say Nginx, right? What this will do is just pull that image back from me again. So it says it downloaded the newer image for Nginx, right? And if I do the Docker images again, I see Nginx here again. Now, one thing I need you to also understand is when you do something like Docker pull or Docker run and you are specifying an image, you have the option to specify a version of that image. Right, we're going to talk about this more in like Docker Hub and all that, but you can specify a version of that image. As you can see, some of these images I have here, they have different versions, right? But when you don't specify any version, you just download the latest. So it's the same thing as me just saying column latest, right? Because this column just separates the or allows you to specify a version of that. So if Nginx had, let me just assume it had a version 4.0.0. I'm not sure it does, but let's just assume and test. Then it should download that particular image for us. Okay, so it doesn't. Okay, let's try something like 0.5, if that's the way it's formatted. Okay, it doesn't. Okay, anyways, once we do the Docker Hub version, the Docker Hub session, I'll show you how to see the different images and all that, right? So that's basically it in terms of the Docker commands. These are just basic Docker commands you can use to navigate working with containers and images, right? So I'm gonna open the floor again for some questions. I'm sure we might have some questions based on what I've shared to clarify anything that I've said, or if you just want me to show something different, just let me know. You can put your virtual hand up, and I'll give you a chance to speak. Do we have any questions? If Paula has a question. Is there anyone else with a question? If there's anything I've said, that is unclear, feel free to ask. I want us to really get a good understanding of Docker, at least this background of Docker that we're talking about, what it is, and just how to navigate it so that you can go on and practice on your own if you've not used it before. So if you have a question, please raise your virtual hand to take your question. So for now, I'll just allow Bolaji speak and hope to see the hands of others. Bolaji, I think you can go on.
All right, thank you once again. So now there is this word you've been using, image. So please, within the IT terminology or concept that we are familiar with, how can you explain image? Because sometimes if you say image, it looks like maybe a snapshot of something. Sometimes I see it, is it like an executable? Is it like a service? Or how can you in like a dummy explanation, how can you give us what image is?
Okay, that's a very good question. The thing with IT in general is that different companies use different words for different things. Or like you mentioned, imaging in Microsoft, for instance, might not be imaging in AWS or in Docker, right? But in Docker's case, when we talk about image, right, an image um, I'll just call it an entity that contains everything that a Docker container needs to run, right? An image has the files, it has the configuration files, it has the binaries, right? Basically everything that the container needs to run. I see here in this comment here, says you can use PowerShell in Windows to run this command. Yes, you can use PowerShell if you install Docker. I think PowerShell has the ability to do that. Image in EC2 is like a snapshot for a backup to retrieve information. Am I missing it up? And clarify. Yeah, so in EC2, an image is like a backup. Yes, it's like a snapshot. It's something you can use. So let's say you have let me go to the EC2 one before I come to the Docker one, since that's the kind of dichotomy we're talking about. Let's say you have a Docker machine running, sorry, an EC2 machine running right now, and that EC2 machine has Nginx installed. It has MySQL installed. Let's say it has some other software installed. Let's even just say those two softwares. And you want to duplicate that EC2 machine. That means you want to run like a clone of it, like another instance of that EC2 machine. But you don't want to have to start installing all those things that you installed previously. Let's say you had like 10 different applications. What you do is to take a snapshot of the EC2 machine, which creates an image. In EC2 or in AWS, it's called Amazon Machine Image. Right? If you take that snapshot, then you're able to create an image from it. So imaging is basically taking what is existing but putting it in a still fashion. That means is turning it into like a template that you can use to run other things, right? So an Amazon machine image, when you now use it to create and that EC2, when the EC2 starts up, it has everything that the last EC2 has. So it's just a way to duplicate it. So, but in Docker, that's not the way it runs, right? The way it runs is you have what you call a Docker file. And we've not got into that yet, but we'll talk about it. A Docker file. A Docker file is basically a file that contains a list of commands right? Or a list of configurations. Let me put it like that. So I think that's a better word. List of Docker configurations that define the configuration of a Docker image or a Docker container. Now, what do I mean? So in a Docker file, you can have a command such as yum install or apt install nginx or apt install mysql or apt install http server or something like that. So it will say it's like a recipe saying that Docker file is like a recipe saying these are the different softwares I want to be installed or the different files that I want to be added to this Docker image, right? And when you now build a Docker file, building a Docker file is really just one command. You just say Docker build. And building a Docker file is taking that file and the different commands and telling Docker to run it and to create an image out of it. So that image is a file itself that contains every binary, every software that the Docker container is going to use to run. So when you say Docker run that image, you're just telling Docker to bring that file in, to bring it to life, right? Since that file has everything it needs, you're just telling it, okay, now run this file, turn this file into a running machine that I can interact with, basically bring this file to life. So in a sense, it's similar to the image that you have on your EC2s and the likes, but the way it's created is different. Images are not really used for backup for Docker. Images are used to as like a blueprint for the container that is going to be run. Maybe to make sense if I show you Docker Hub and different images that are on Docker Hub. So let me just bring that up here, even though we're still going to talk about it, just for the sake of this question. Right, so Docker Hub is an image library. This is the URL hub.docker.com. Let me just do a bit of zooming in here. Into 100% should be good for us. So now, let me go for Nginx again, since something we're familiar with, right? So, okay. So here it just gives the background of Nginx and tells you how to use that image, right? So when you come to somewhere like Docker Hub, you'll see that different vendors, right? Different software providers. You can see things like Redis, Memcache. Even if I check for MySQL, if I search for MySQL, you see MySQL here. Different vendors have created their own images, which again, they are files that are just templates or blueprints used to run these containers, right? They have packaged it with everything that those images need. So if I go to, let's say, let me go to one of these tags, and this one says Oracle Linux. Let me just look for latest here, right? If I come to latest and I see, okay, so you can see here in this part where it says layers, what you can see here is all the commands that it runs to ensure that MySQL runs successfully, right? So all these commands are inside our Docker file, and they are built into an image that is compatible with Docker, something that Docker can run, right? So I don't know if that makes sense, if that gives you like a better understanding of what an image is. In a simple definition, an image is just a file that has all the commands and binaries that a Docker container needs to run, so that when you run that image, everything that it needs to run your application is in place, right? So I think that clarifies things. But I just put in a thumbs up. But please, if it doesn't, still let me know. I can still speak to it a bit more. Okay, so do we have any other questions? Nico says it's good. I'm glad to hear that. Any questions? None. Okay, all right, great. Let me see what we have left. Okay, so what we'll do is just talk a bit about Docker images some more before we end the class. I know we have about 30 minutes more. So Docker images. I know I've kind of gone on and on about them, but I'll just talk to them a little bit more from the slide. So Docker images are the building blocks of containers, right? They are lightweight, portable, and self-sufficient packages that contain everything needed to run a software application, including the code, the runtime, the libraries, and system tools, like I mentioned, right? Docker images, just like a recipe book or a template, contains all the instructions you need to create that beautiful Nginx dish, which is in this case a running container. So the code that we mentioned here, so I said code, runtime, libraries, and system tools. Excuse me. The code is the application itself, right? Which will be Nginx if we are talking about Nginx container and Nginx image. The runtime would be the environment in which the application runs, right? So if you are looking at it in kitchen terms, the runtime is something like an oven for baking, right? That's where the oven, sorry, that's where the bread or the cake, is made, right? So that runtime that enables the bread or the cake to be made, that oven, that's the runtime. The libraries that we're talking about here, there are things like in kitchen terms, they're like specific spices or condiments, your salt, your pepper, and all those kind of things needed for the dish. Then the system tools, those are like kitchen utensils that you need, your forks, your knives, and your spoons, and all those kind of things that you need to prepare your meal. So all these things are the components of Docker images. Those, the code, the runtime, the libraries, and the system tools, right? One thing to note about images is that, like I mentioned, they are portable, they are lightweight, but they are self-sufficient, right? Each image is isolated from other images, right? So each image has everything that it needs without, borrowing or affecting another image, right? So it ensures that when you run an application from Docker, it will behave the same way regardless of the environment where you run it, because it has everything that it needs. Another thing to understand about images, I think we saw that on Docker Hub, is that images are built from a series of layers. Now, this is very interesting about images. They have what we call layers. Each layer represents a change or an addition to the image, right? It's like creating, let's say you want to create some sauce or some dish. Sometimes you have like a base sauce, then you add ingredients to it to modify it for every dish. For instance, for the Nigerian South Africans among us, you can use your stew, for instance, as just a normal sauce for your rice, your white rice. You can use your stew to also make, some people use it to also make jollof rice, depends. You can use your stew with okra, for instance. I hope this analogy is actually getting through to everybody. I don't know if everybody's familiar with this food, but I'm just saying, like, stew in this case is like a base sauce, and you can put other things on it, right? So Docker images have layers. It has like the base layer, then it has several layers on top of it, depending on the different changes or additions we make to it. And I can just show you that here, as we saw here, we saw layers, right? We saw that, when they run this command here, which we'll talk about later, that was, so we had a layer 0, right, which was this Oracle Linux 8 Slim, right? Then we had another layer when they run that command, and that layer, then see that this container has like 19 different layers, right? And each layer just represents a different command that has been run, which we'll talk about all these things. Don't worry too much about them right now, but just understand the concept that images have layers, right? And each layer kind of builds upon the last one. Okay. So now, Docker Hub, which we've spoken about, is a cloud-based registry service provided by Docker themselves that allow users to share and distribute containerized applications and services. It serves as a central repository for Docker images, and which allows with portable and self-sufficient containers, as we've mentioned already, right? So Docker Hub can just be thought of as a public library instead, but instead of books, you have Docker images. Right? Their library allows anyone to download. That's like in terms of like borrowing books, but in this case, images, download images and upload their own images to that library, right? So it's just a central spot for developers and companies to store their images. So on Docker Hub, you can have what you call a private repository or a public repository, right? When you look at Docker Hub here, whatever you can see when you search is a public repository, right? If it's private, you will not be able to see it when you search, except you are logged in and you are the owner of that image. Then you'll be able to see the image when you search, right? What else? So one thing I wanted to mention was what we can see in this diagram, right? Which is a process, of Docker images, right? Okay, we've actually talked about this. A Docker pull, Docker build, Docker run, and all that. Okay, we've actually covered this, so we'll just move away from that. One of the other features of Docker Hub is that Docker Hub can automatically build images from your code in your repository whenever your code is updated, right? So if you want to share your images on Docker Hub, you don't always have to manually push it. This is something we do in my company, right? In GitHub, there's a way you can configure it so that if you make a change to a file, it will automatically update it and push it to Docker Hub with a new version, which is what basically almost every company does, right? And one thing that Docker Hub does in the context of the DevOps culture is that it supports the DevOps goals in terms of speed and agility by providing a ready repository of images that can be quickly pulled and deployed anytime, which streamlines your deployment process, right? If you see any CI/CD pipeline, you see that they are pulling images from somewhere and sometimes even pushing images somewhere, right? But they'll usually, if there isn't containerization, they'll usually pull an image, then use it to run a container and all those kind of things. And most times they're pulling it from Docker Hub, right? It's rare that you see that people run their own private images, except they really need them, right? So another concept we will talk about is Docker files. Docker files. A Docker file is a plain text configuration file that contains a set of instructions for building a Docker image. right? So you go from Docker file to Docker image to Docker container, right? So the Docker file serves as a blueprint for creating a reproducible and consistent environment for your application, right? They are fundamental to the containerization process. So in Docker files, you can define the steps to assemble an image that has your application and its dependencies. And Docker files are they're very great concept because they make the Docker containers consistent and reproducible, right? So you can easily create your Docker containers or Docker images from scratch anywhere as far as you just have that Docker file, right? So that is very helpful. And if we look at the basic syntax of a Docker file has it has its own kind of, I want to say, language or grammar, which is not really difficult. It just has certain things that you use to ensure that you have everything that you need with Docker image. Now, so some of the key syntaxes or commands in this case, something like from, right? From specifies the official base image that you'll be building upon, that's coming from Docker Hub, right? It's like selecting a foundation for your building. Some people say, but there are different kind of foundation if you're into building. I think there's like the German floor one, or there are different ones, right? So it's saying, oh, this is the foundation I want to use to build my Docker image, right? So and when you choose that foundation, the reason why you will use from in a Docker file is because you don't want to reinvent the wheel. There are Docker containers that have maybe 90% of what you need, and you just want to add 10%. So rather than creating your own from scratch, you just specify that container and add some things to it. Sorry, that image rather, right? That base image, then add some things that you need into it. So if we look at Docker Hub here, when we even searched for MySQL, they did something like that. They did exactly that, right? What they did here, I'll go to MySQL and I'll go to latest. So what they did here in this layers, you can see they did from first before they started adding everything else that they needed. So from in this case was just saying that Oracle Linux 8 probably has 8 Slim in this case, probably has most of what they need already. And they just want to add a few more commands to it to make it MySQL. So they used the from there, then they added everything else that they wanted to do, right? So that's the from command in this case. Then you have the work dir command. This just specifies the working directory in the container. So it's saying, I want to set the working directory to this in the container. I know we've done working directories on Linux machine, so it's very similar. It's just saying, oh, now, okay, previously, let's say the working directory was /home or something. Now I want it to be /temp. So you just say working directory space /temp. That's how easy it is, right? Then the copy command here just copies the local file to the default public directory inside the container. So you can also specify different directories. It doesn't have to be the default, but copy command just allows you to copy local files from your local machine into a container when you are building that image, right? So expose is a command that informs Docker that the image will use a certain port. Right? In this case, we're just using the example of expose 80. It can be expose any port, expose 2000, expose 90, or expose 22, whatever it is. So it doesn't, it's more of a documentation feature. It doesn't actually publish that port to be open to use, right? But it's just saying, letting Docker know that, okay, this port will be used by the image that is going to be created from this Docker file. Then we have the run command. Run command executes a command during the image build process, right? If you wanted to, for instance, install, npm, right? Or you wanted to install something in Node.js using npm install, you just write run npm install something. If you wanted to install it via apt.yum, you can say run apt install, run yum install. So it just basically executes the command that is after that run, right? Then the last one here, cmd. Cmd provides the command that will be executed by default when the container starts. So when you run a container, cmd it holds the command that the container will run first, right? And I'll show you that in an example. So let's do a little bit of a demo before we close. I think I have something for a demo. Okay, right. So let's create. Okay, let's make a directory called Docker container. Right? Sorry, that's make the IR. So let's go into Docker containers. Now, let's create a Docker file. Let's call the Docker, you can just call it Docker file, right? I can say vim Docker file. So, what I want to do is create a Docker container from, let's say, so this from command now, I can do something like from node 14. I want to use node as my base image, version 14. Then let's say I want to run, it would have been good for me to get a package JSON. Okay, let's do this. Let's get a sample package JSON. Let me do something like npm install. Let me just get something from the internet for us to do a quick demo. Yeah, just give me a second. So let's just say sample. You can also use this to sample package JSON, a package of JSON for Node.js, right? So we can just use something like this for simple package JSON, right? So I'll just copy this just for a simple test. So don't mind me. So I'll just create a package.json file. Just paste this in. You don't need to know this part specifically for Docker. This is just because I want to do this demo for us very quickly. So what we can do is create that Docker file now. Say from node 14, and I want to say my working directory and put that in the uppercase. So this is how you use the working directory. Just say, put the directory name, right? Then I can say copy and package the JSON. That's that file that I just created. My local machine, copy it to this working directory here, /app. and I can give it a run command to say npm install, right? This command is native to or specific to Node.js. So it's not something you specifically need to know. It just depends on what you're trying to achieve with your Docker file. Then let's say copy if there are any other contents, let me just say copy what is in my local directory. With this dot, it just says copy what is in the current directory to the app, the slash app. Then you can use expose AT. Then we can create an environment variable. I don't know if we talked about that, but env enables you to create an environment variable. So I'll create an environment variable called name. Then I'll say, let's call this Diary students, right? Then I'll do a CMD, which is, if you remember, it's the command that the container is going to run when it first starts. So let's hope this works. So this is typically how I'm mostly just showing you this for how you write a Docker file of your own, right? You might not need to write all this code. If you don't need to use like the working directory, don't use it. If you don't need to copy a file, you don't copy it. So you don't need to use run. But if you need to use them, it's just good for you to know them and know how they work, right? So if you are going to build a Docker file, you will just run something like this: Docker build you can use -t, I believe that should give it a tag. Let's call this Docker build tag v1. Then the dot just says that it should look for the Docker file in the current working directory. That's what the dot does. Let's try this and see if that works. Okay, so interestingly, it's building. Let's hope it succeeds. So you can see here it's downloaded the Node 14 that I asked for as the base image, right? And let's see what else it's going to do. See, it's downloading different layers. All these things are layers that you're seeing. Then let's just give it a second. Still extracting. I think that's the main thing that is causing it to run for a bit here. Okay, it's extracting another file. Yeah. Okay, so now it has gone to the work directory step. See, it has copied the package.json, completed that step. Now it's running npm install. Okay. Oh, wow. Okay, so it was successful. So it copied this and it exported the image. So now if I run Docker images, I should see my image called v1 here. Okay, so nice. We see our image here, although it's quite big, 916 MB, but it exists. So if I was to try and run this image interactively, I'm just curious to see if it will work. Let's give it a name called wisdom image. And let's use our image name called v1. Let's see if it will run interactively. Okay, maybe not. Let me try and use, does it have a bin, bash? Okay, something is already running. Let's just, sorry, give me a second. because I created an image, sorry, a container with that name. Even though it failed, it still has that name. So when I try to create another one, it tells me that name is already in use. So I can just do a Docker remove wisdom image. I should have said wisdom container. That's a better name than wisdom image, actually. All right, so let's try it again like this. Okay, so now we can see that it allows me to log into that container, right? That I created with my image. So I just want to test something that we tried. If you remember, we created an environment variable called name. I want to see if we have that environment variable here. So what I'm going to do is echo that environment variable. And you can see we have that students. That's what we put in that environment variable, right? So this is just a crude example as to how you can like create a Docker file. Let me give you a view of that Docker file again. Oh, sorry, I'm still in the container. So view of the Docker file, you can just see just these few commands here to get it running. And there's so much you can do with it once you just kind of understand the concept of it and just practice with it, create your own Docker files, create your own containers and all those kind of things. So I think I would like us to stop here for today. And let me get our questions if there are any from anything that has been discussed before we round up for the day. Do we have any questions? If you do, please raise your hand and let me know and I can speak to them. Practice needed. Oh yeah, for sure. For sure. Practice makes perfect. Just test things out, try them. You find it very, very easy. Like I said, there's very, very good documentation. If you just go to Docker and docker.com, you click on documentation here. You click on documentation here and look at the guides. For instance, if you wanted to do, okay, let's just go to guides. Right, so these are Docker concepts here. All these things that I've talked about, except Docker Compose. But Docker Compose is not really a necessary thing you need to know. Building images, understanding, writing the Docker file, which we talked about here. You can just come here and read about it. So there's very, very good documentation for you guys to just go look through. There's even a video here. You can watch that, understand more about it. But what I've done here, I'm sure should give you like a good grasp of these different concepts. Timothy says I was late, but I'm still struggling with shell scripting for the past 2 weeks. Okay. Timothy, you can definitely reach out to people in the Slack channel or your fellow colleagues. Some of them have gotten a good grasp of this, so you can ask questions and you definitely receive help. We might not be able to talk about that in this class because of time, but I'll just urge you to reach out to people. Don't try to solve everything yourself, because it most times doesn't work. Trust me. Even for me, I still have to do that as I move on in my career. So please reach out to people, and I'm sure you'll receive help. Yeah, Slack is great, as Fiordo said. Okay, so I'll just ask for questions one more time. If we don't have any, we'll call it a day. Okay, no questions. Thank you everyone for joining the class today. And Nico has a question. Okay, awesome. Nico, let's take your question before we round up. I love that.
Hi, good evening.
Good evening.
Yeah, it's been an interesting class and I'm learning so much.
Oh,
So
I'm
there's
glad to hear
something I
that.
learned about, yeah, there's something I learned about Docker and VMware. Learned that Docker is not prone to error. Like you can run basically let's say every of your programming or every of your code, you can run it seamlessly on Docker compared to VMware where you have to convert. So I mean, maybe let me give an example. Let's assume I am a developer and we have another developer, then we have a DevOps engineer. So let's say I'm using VMware like a virtual machine, then I'm running on that machine. From what I learned, you will still need to convert. Maybe you are using let's assume you are using PHP for your backend and you are using some other languages. So before you can run the program across board, you have to convert it to what will be run very well on another
And
machine before.
VMware,
But
yeah, on a different machine. Yeah.
unlike Docker, you have to you can just run it like that and it will work. So I want to
Yeah.
ask, is there anything that makes Docker work on every of those you don't need to convert? Can it be the containerization where they are in container, or there is a particular environment that supports Docker to run every code, every line of code seamlessly? So that's my question. Hope you get what
Okay.
I'm trying to say.
Yes, yes, I get it perfectly. That's a very good question. To be honest, it's what we've been covering from the beginning, in the sense that what enables this to happen is the. Sorry, Lekon, can you mute for a second so that others can hear? I think there's a bit of background noise. Okay, thank you so much. Awesome. So what enables this to happen is the fact that Docker is quite portable, right? That means it only runs what it needs. It doesn't run extra things that are unnecessary. And number two is that Docker runs on a Docker platform, which is uniform across board. So on any machine that you are, once you install the Docker platform, you're able to run your Docker container on it the same way. But when you think of something like virtualization, you have VMware. If you run something on VMware and you need to run it on Hyper-V, like you said, you need to convert VMware to Hyper-V. If you need to run it on KVM, you need to convert it again. So I think where Docker wins is that it has a universal platform across board, which runs the same way on every single operating system that you run, which then enables you to run your containers on that platform seamlessly, right, without having to do this merry-go-round and many changes. So I hope that makes sense. I hope that clarifies your question, Lekon. The platform is the key part of it. Awesome, awesome. Thanks for confirming that. So as to not take our time, thank you so much, everyone, for joining this evening. I hope you have a great night's rest if it's night where you are, and I hope to see all of you next week. Please practice, 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 and we'll see you next week. Have a good night.